Good afternoon, everyone. Welcome back to Tech Talk Tuesday here at Treadwell. Today, a little bit different to what we sometimes do. We're going to be having a look more at, excuse me, some application-specific type scenarios, a couple of costing comparisons, a few things like that, specifically related to structures or project applications in mining. Now, why mining this week? A couple of reasons. Firstly, it's Amex in South Australia this week, the mining show. And secondly, it's WA mining in 2 weeks' time. So we thought we'd do a bit of a run through for our mining clients on why FRP, what FRP brings to the table, why you might like to consider FRP, and then obviously the million-dollar question, for want of a better term, around how FRP compares from a cost perspective, both initially, so purchase of material, but then any differences around installation cost and those type things, cranes and labour and all that sort of stuff. And then lastly, a bit of a discussion around life cycle. So without any further ado, let's get started. We'll have a look at a couple of sites where we've done some work, we'll have a look at a couple of specific projects, and we'll use one of these projects as a bit of a case study, if you like, talk through some costings and budgets and that sort of stuff. So any questions? Q&A window is open right now, so anything comes up, please feel free to put it on the chat as we proceed, and then we'll either answer it as we go or at the end. And lastly, any advice we discuss around standards and things, as usual, is general advice. Shouldn't be taken as site specific, but we can arrange discussions on site visits, that sort of thing, to discuss any site specific requirements you might have. So why FRP, excuse me? Why FRP in the mining industry? What does FRP bring to the table? There's three main benefits that our clients find with FRP around mining and minerals. And a lot of these apply really to anywhere, but in the context of mining. Firstly is the corrosion aspect, especially around process plants. A lot of process water is very saline, limited water usage allowed. Second is obviously we have some reagents, sometimes can be corrosive on materials, and then we get the slurry build-up on structures that leads to accelerated corrosion with something like on your typical steel structures where slurry builds up and accelerates corrosion. So that's the corrosion aspect. Secondly, FRP is non-conductive. That's beneficial around some electrical equipment, substations, high voltage, that sort of stuff, especially for things like cable trays and cable ladder and services routing. And third is FRP is lightweight. So a lot of limited access. We can reduce scaffolding. We can use smaller cranes. We might be able to bring things in and stick build them. And then the lucky last is FRP does not need any hot work on site. So FRP is typically bolted connections or mechanical fixings. However, even if any modification is needed, cutting, drilling, trimming, that sort of stuff, it's not a hot process. There's no sparks given off, so hot work or a hot works permit is not needed. We've mentioned corrosion. FRP doesn't oxidize when exposed to moisture, chemicals, reagents, all that sort of stuff. We've discussed the lightweight and had a lot of feedback from clients. We'll look at a couple of projects in due course regarding this, where FRP is actually saving a reasonable amount of cost during installation, and we'll look at a specific project a bit later on in the presentation and discuss why that was the case. We've discussed easier handling, reduced downtime, helps us get projects completed more quickly. So now we're into a few case studies. This is a salt facility, WA. Obviously, salt and evaporation facility is corrosive, but there's another point here. This is in the Pilbara. There's a lot of cyclones and high winds and those sort of things, and any structure relying on a coating to protect it, like steel, say, with a coating from a corrosion perspective, is effectively salt blasted or sand blasted, and the client was finding that protective coatings weren't durable, which obviously leads into the idea that corrosion was happening more quickly than desirable, than ideal, and causing higher than desired maintenance costs and downtime and so on. So you see my mouse, this full structure, staircase structure on the side of the conveyor, and this little bottom staircase here, that's all FRP. So the handrail is FRP, the stair treads, gratings are FRP. The structural profiles you see there, so the C channels, the square hollow section, and so on, is all FRP. And can't really see it here, but underneath this structure is a suspended FRP cable ladder as well. So full FRP structure there, and Treadwell's scope was design, supply, fabricate, so a prefabbed, pre-engineered structure delivered to site to be installed by the client's team of fitters and boiler makers and so on. Another project we completed, you can see only a small amount of it here around the drive end of this conveyor, but you can see my mouse, some mesh here and some structural members, some columns. That's a non-metallic conveyor guarding system as well, so all FRP. Good feedback around corrosion and durability there. Now, this is another one, and this was what I wanted to specifically mention around install cost savings. Now, as you can see here, this is in a channel. So firstly, a client was finding the lifespan of a steel structure in this application that was both hot dip galvanized and had a 2-coat epoxy coating system on it. Might have been 3-coat, but heavy coating specular. Now, the client wasn't happy with the lifespan. I think they got about 5 years out of the structure, so quite a corrosive environment. Now, there's another thing, which is, as you can see, access here is somewhat limited. So, because to reinstall a steel structure, there was going to need to be some bank stabilization, ground shoring, those sort of things to bring a large enough crane close enough to be able to install this structure. So, firstly, we talk about the cost of materials, and in round figures, I think a steel structure was somewhere in the order of just over $100,000, 110, 120 grand, and the FRP structure was about 130. So not a significant cost increase for initial materials. That's number one. But secondly, obviously some reasonable cost savings around the install. The fact that I think it was just a franner that was used, or a very small crane with no bank stabilization, was able to lift in these modules. So the tower was constructed in 2 halves, if you like. That was lifted in, and then team was able to install the cross bracing and members to form a complete structure. And then this bridge that you see here, 9-meter span, was pre-assembled by Treadwell and just lifted in one piece. So quite a good cost saving around install, but also quite a good time saving. And lastly, we supplied this structure in the end of 2014. So it's very nearly 11 years old. It's over twice lasted the steel structure already, and we'd expect that structure to continue its lifespan for quite a long time. I think that was done with a design life of 25 years from memory, and that's not specific. It's not just related to the lifespan of the material, but also the design methodology. In some of our other webinars, you'll note we discuss some design methodologies, and in fact, there's some little variances to deal with the nuances of FRP over a longer design life, and some slight variances in methodology depending on the design life we're after. So here's a good image of this. You'll also note there's a lot of fixings in these corner connections, especially, and that was a client request. They replaced fixings on a periodic basis from a risk mitigation perspective. So they wanted to be able to replace half the fixings at a time without having to take the structure out of service, and know that while they were doing that, it could still continue to be used, and it was structurally sound. So another design criteria there. This is a gold processing plant. Similar idea, similar theme. These are all FRP handrails. You can see here some FRP staircases and access. As you can see, this is in the processing plant. So corrosion battles and costs that come with blasting paint regimes and those sort of things. So good low maintenance, but also worry-free installation for the client for things like handrail, where they can be confident that it's not corroding internally, and the only way they find out is suddenly when someone gets injured or a handrail fails catastrophically or something like that. Another couple of projects in WA, some nickel in these instances, a lot of cable ladder and cable tray for some of these sites here, as well as the standard products such as grading walkways, all that sort of stuff. This is another interesting one. This is an ammonium nitrate facility in New South Wales. Number of FRP solutions used here. So floor grading, this is a solid surface FRP floor grading, FRP handrail, and then some of the FRP treads and so on these stairs. The main structure you can see is steel. However, some of the intermediates are FRP. Hot works obviously is a problem in this environment. Hence, FRP's benefits, and also lower the weight, the easier it is to install. This is a multi-level bagging tower, so it needs to be easy to access, limited craneage and so on that can be used there. Another example here, this client's had some of our handrail in service for, I'm just trying to remember when it was installed. It was quite some time ago, I think in the order of 12, 13 years. A little while ago, they removed the section and sent it in to get tested at a NADA-approved laboratory as required by the AS 1657, and that handrail passed the test requirements still. So still compliant, still fit for purpose, still structurally sound after many years service in which was a fairly hostile environment. This here's another interesting one. Conscious of everyone's time, so I'll try and keep moving. This is a cover for Jamison cells. Client wanted to facilitate odor extraction. That was one of their permitting requirements, I think, due to some proximities of this processing plant upgrade to some residential locations. So we supplied a solid top or solid surface FRP grading, and then we supplied some integrated hatches. You can see here that was all prefabbed and supplied by Treadwell, and they're able to be just opened quickly and easily. They're lockable if desired for security, but they can just be opened easily and quickly for any inspections, any sampling that needs to be done on a regular basis. Look, I'll skip over a couple of these just really from the time perspective, because I would like to have a discussion around this. So now we'll very briefly discuss what we mentioned, a steel versus FRP structure with a high grade coating. Now, cooling tower structure, we'll look at what that looks like in FRP shortly, but a couple of things to think about here, which is why the client went to FRP. One is obviously they'd tried steel, they weren't happy with the lifespan, they'd even tried timber and found some drawbacks with that, including the lifespan in a very wet environment not being what they hoped for, but also some logistical challenges, getting timber and fabrication, all that sort of stuff. So a few synergies or a few benefits the client found with FRP. You can see a cost here. So there's a cost premium for the FRP. I'm not going to try and throw a quick percentage at you. I'm sure if anyone's good at maths or nearby, they can work that out. But there's a cost increase, as you can see there. However, there's a few, as I said, synergies the client found. One was the fact that design engineering was done in-house here at Treadwell for our structure, rather than having a third-party design and engineer, and then another party do some fabrication, perhaps another party again apply some coatings. So took a number of moving parts out of it, which is good from a workflow perspective, but also good from a communications perspective, where one party can give updates on how the project's progressing. Second is they had concerns around paint coating damage during transit, rubs, scratches, scrapes, scuffs, those sort of things, and where the structure starts to degrade once that happens. And then the fact that we were able to provide a design life based on material in service and our experience, and also sorry, I just lost my train of thought. We were able to provide a design life based on experience, based on the design methodology, and based on material had in service, and some associated companies have had in service for quite a number of years. Now, How that compares with the steel structure is obviously we've had feedback that sometimes coating manufacturers are not adverse to providing application or lifespans if they're not just based on around applications. Who does the application might be a bit of a disconnect between fabrication, blast, and paint and the supplier. So, hence, once again, a bit of a streamlining effect here where Treadwell is bringing in all those things in-house, design, engineering, fabrication, a bit of a smoother process. The other thing was, once again, lighter structure self-weight. So the client found some reduced cost of footings and reduced craneage cost to put those in, but also a greater ability to do some prefab and minimise time on site. Um, and lastly, if any site modifications were required, so a little bit of a trim on the handrail or on a floor grading or something like that, as being constructed, there's no coating damage, so we don't need to send the structure off to get blasted and painted or try and remediate it satisfactorily on site with some sort of cold zinc coating or spray or something like that on site. But also, once again, no hot work, so no safety issues around that. Here's our finished structure. So this is all FRP, columns, beams, bracing, handrail, floor grading, stair treads, everything here is FRP. And we work with the cooling tower manufacturer to integrate into their structure what they needed as far as the FRP being able to provide support for itself as necessary, and anything else, some of the pipe work and things, the FRP structure needed to support that. And also make sure that there was a good interface. You can see their continuous handrail here onto the top of the cooling towers from the platform. So nice, easy access for maintenance and inspections and those sort of things. Sorry, we've run a little bit over time, but that's the end of our discussion today. Back in a couple of weeks for another Tech Talk Tuesday. In the meantime, any questions, give us a call, 1-800-246-800 for Australia, 0800-244-600 for New Zealand, or drop us an email, hello@treadwellgroup.com.au. Always happy to see questions, always happy to discuss projects. If you'd like some samples, if you'd like someone to come to site and have a look at some structures and comment on how we might be able to assist with perhaps some reduced maintenance costs or improved access or reduction in sleep issues or anything like that, give us a shout. Always down to head out to site and have a look. Our technical team is always interested to help optimise however we can to provide an easy to install and cost-effective structure. Thanks again for joining. Doesn't seem to be any questions come through. We'll just stay on for half a minute or so in case anyone thinks of anything. Otherwise, drop us a line, give us a call, or we'll see you again in a couple of weeks. Doesn't seem to be any questions, so we'll wrap it up there. Thanks again for joining. Appreciate all your support, and we'll see you on the next webinar. Cheers.